simulation of a car. We consider a car described by the state equations that are given here. And in this exercise, we will try to simulate this car and to draw it on the screen. So the state is x, y, theta, v and delta. X, y, theta correspond to the degree of freedom of the system. V is the speed, and delta is the angle of the front wheel. So this is my system. I will have here x and y, and what I need first for the simulation is to draw the car, and then I will simulate using the Euler method. So I notice that I have something like x dot equal f of xu. This is the evolution function f of x and u. X correspond to x, y, theta, v and delta. Xy is the center of the back axle, like this. So this is the two wheels. This is the car. I will draw like this. And I have the front axle like this. And the two front wheels like this. Here I will have x. Here y. The angle theta. And here the angle delta. Delta is the same for the two wheels. We assume this. So it is very similar, as I have a unique wheel like this with the same angle, and this is why sometimes we call it a tricycle model. Here I have also another parameter which corresponds to L, and L is the distance between the two axles. So first I need to draw this, and to draw this I will have to build the sketch for under the form of a matrix of the chassis. So that's what I will do now. So this is the chassis. I have the two back wheels, and I did not put the front wheel. I will do it later. So why I have to separate? Because this one can move with respect to the red part, and this part is immobile in the sense that, or rigid in the sense that if I take 2 points, for instance this point and this point, then in the picture the distance between the two of them will be fixed. It is not the same if I take a front wheel like this, which will move. The distance between this point and another point, for instance this one, may change. This is why they have to be on a different sketch. I consider here to draw it and to build my matrix, which is given here. Something like this. And I will have several points. The first point may, for instance, be this one. So the 0 is here. I will have here -1 divided by 3, and here -2 divided by 3. So this corresponds to this point. Then this one corresponds to this point. This one to this point. this one to this point, and so on. So what I have to do is I should be able to draw without lifting the pen. I should be able to draw everything like this, all the sketch coming here, for instance, without lifting the pen. And if I do this, I have a set of points that are represented by this matrix. Now I have to transform, I have to transform into homogeneous coordinate, but also I need some time to be able to change the size, because in my picture the distance between the two axles, like this, is equal to L, and in this picture L is equal to 1. But it may be different, and in the exercise I need to have L equal to 3 meters, like I would say like a big car. This is why I will multiply this one by L, because L is 3 meters, so by 3. Now from this matrix I have to transform into homogeneous coordinate. So for this I have this matrix, and I should, from this matrix, so this is a big matrix, I will to add a lines of 1 everywhere. Take care, the 1 that are here should not be multiplied by L. And from this I will be able to draw the sketch on the screen. I propose the following Python program just for drawing the chassis. So I have the matrix M here, which was given previously, and I will multiply by L here, and it corresponds to the chassis. I made a small function for the initialization, which I always use in this course. I create the figure, I define the xmin, xmax, ymin, ymax for the scale, and I clear the picture. And the clear the picture is by this, so CLA clears, and I also fix the limit of the two axles, the two axes. I also define a plot 2D, which takes this kind of matrix, an array in NumPy. NumPy is here, and array is here, so now I can use it because I have imported it. From Matplotlib I have imported everything to be able to draw things. So this function will draw red, and I can fix the color, and by default it is black. W corresponds to the width. This is why when I put 5 it will be quite thick. I run the program like this. I run, and this is a picture. Okay. If I change the length, for instance, if I put 8, I will obtain something greater like this. Okay. If I put 1, I will obtain something small like this. If I put here 1 and blue, I can understand that it will be thin and blue, like here. I have my object corresponding to the chassis. Here my plane, x and y, and at the beginning, this, which is represented by a matrix, is here. Exactly here. Now what I want to do, I want to translate it by x and y, and then I want to rotate it by an angle theta. So the translation is, I take this point, I will translate by x and y, and I want also to rotate by an angle theta. So I will start first by the rotation theta, and from the matrix corresponding of my system, which has 2 lines, I have to add 1 like this to transform into homogeneous coordinate. This makes me a sketch, so I will call it, for instance, M. To rotate it by an angle theta, I have to multiply by a rotation matrix. Let's say rotation theta, which is equal to cos theta minus sine theta, cos theta, 0, 0, 0, 0, 1. If I want to translate it by a vector x and y, to put it here, I will use the translation, so the transform translation, which is given by 0, 0, excuse me, here it's 1 and 1, 0, 0 and 1, and here I will have x, y, 0, 0. So what happened is that if I compute t multiply by m, then I will translate the car which corresponds to m. If I multiply by r theta, then if I put r theta multiplied by m, it makes me rotate the car. So as a consequence, just to put the car at the right place, I will first rotate. So I will take m, I will rotate, and then I will translate by x and y. X and y. Now I also have the two wheels to put. So at the beginning, I will make a wheel like this, and this wheel will have a shape which will be given, let's say, by this. And I will take for this shape m wheel. It will be given also by a matrix, so minus L plus L, for instance, to do something very similar to so minus 1 plus 1 or minus L plus L, because I will have to make it similar to my object. So 0, 0, because I have no y coordinate, and 1, 1 to put everything in homogeneous coordinate. Then to put here at the right place, what I should do? I should first rotate by an angle delta to put like this. Once I have done this, I should translate to put at the right place. So this is why I will put this here. Okay. So I rotate first, then I will translate to put at the right place here. I will do this for the left front wheel, but also for the right front wheel. So the rotation will be the same of an angle delta for the two of them, but the first translation will be different. And once the wheel has been placed, then they should receive the same transformation as the chassis itself. So this is why I will translate by this program. So I define here my two functions. One corresponds to the translation here, t equal 1100 x y 001. Here translation. The rotation by an angle A, as given previously, was given by cos A minus sine A cos A 0, 0, 1, 0, 0. This is this matrix. Then here it is a function which add 1 everywhere. So from this matrix, I multiply by L to have the right size, but after I will add 1 everywhere thanks to the VStack, which add call a line of 1 to M in the vertical concatenation. So it will add once like this on the last line from the previous M, which was given here, and this is the new M. As said previously, if I will build my transformation matrix, which is a composition of a rotation by theta and a translation by mx my, which correspond to the x and y where the state x, recall, is made by x, y, theta, v, delta. All of this are put in a list, and to do not make the confusion between this x and this x, it is called mx, my. So mx and y, I take this, which is a vector I put in a list. The list will be mx, my, theta, v, delta, which is what is done here. Then the rotation will be by theta, the heading, and the translation by mx, my. Now for the wheels, I build the wheels here, the front wheel, and both of them will be rotated by delta. This is for the left, this one for the right, but one will receive a translation, this translation, this translation, one to go this translation, and the other one will be this translation. This is my initial vector, and from this I will draw the car. Here. So let me run this. This is my my car. So assume, for instance, that I rotate by an angle theta, let's say 1, and I translate by 1 and 2, and the heading I put it, for instance, 0 as previously. I run the program, and we see that the wheel turn left. Here, if I want to change the heading, for instance, to 1, then I will see that the car has rotated like this. If I want my wheel to turn right, if I want to turn right just a little, I will put here minus 0.1. Let us see what it means. We see that we turn a little on the right. For the last question, I have to perform the simulation. So to program simulation for the evolution of the system for 5 seconds. I will use an Euler method. The sampling time is fixed here. The initial state is also fixed at this, and 50 correspond to the initial speed. Okay, so now I will ask you to turn the front wheel left with a speed equal to 0.05, and there is no acceleration. I take my evolution function, which is given here, f of x and u. I will apply an Euler method which tells me that x at time t plus dt, where dt is small, is taken here at 0.01, is something like x of t plus dt multiplied by f of x and u. this Euler program, the Euler scheme is given here. This is a constant input, so zero acceleration, and I just turn the front wheel left at a rotation rate of 0.05 radian per second. So I clear at each step the figure. I draw the car blue with corresponding L, which is involved also in the state equation. So the L here corresponds to the L here. This corresponds to my function f. This is the initial condition where for x and y I take 0 at the origin. The initial heading is 0. The speed is 50 meters per second, but since I have no acceleration here, it will remain 50 meters per second forever. And the initial angle for the wheel is delta equals 0, but after it will change due to this one. Indeed, I turn left, and it will change the value of delta as expressed here. This one corresponds to u2, and u2 will change the last state variable, which corresponds to this one or to delta. This is a program. I run it. I see that I turn left and the angle of the front wheel turns more and more. It's difficult to see here because at the beginning they are still almost straight, but I see here that the angle is increasing, and more the car is turning left.